Hello, welcome to our final team presentation. Batteries not included. This is for Team 7, also known as Manhattan Project 2, and our team members are myself, Nicholas Hawkins, Jose Hurtado, and Richard Wright.
So our problem statement is maintaining a clean household is a chore that many people like to ignore for a variety of reasons. Time, lack of help, the idea of it being pointless since it's going to get dirty again. All these being reasons as to why we decided to develop robots to aid in this aspect. A swarm of robots that takes away the worry and cleans the house for you, both indoor and outdoor. In the efforts to maintain a clean household, we fall short in many aspects. Amount of time to clean, missing certain tasks, and flat out not wanting to clean. These robots will eliminate that burden from us. We'll be addressing indoor and outdoor upkeep. This idea will bring value both technologically and individually with innovating modern technology to aid in consumers' everyday lives. And in doing so, allows customers to have more time with family and friends.
So who benefits from these, you might ask yourself? Well, first and foremost, customers will benefit from these marvels. No longer are they slaves to their homes, but they get to actually enjoy them. People work hard for their homes. They want a place where they can kick their feet up, not get on their hands and knees and dust and clean and mop and polish. Furthermore, not only do people clean their houses, they clean their businesses. These robots let customers come into a clean business. Those business owners get to engage with customers. They get to set these robots up and let them clean the store while no one's in there. Robots don't need breaks. They don't need sleep. They can be run while no one's in the business. They don't need a contract to work like you would have to hire a house cleaner or a business cleaner. So minimal cost at startup gets you three beautiful swarm bots to take care of your inside and outside of your home, your business, you name it. And people who have mobility problems even can benefit because, no one wants to see their grandma on their hands and knees scrubbing the floor if they can let the Johnny Five take care of that for them. Nobody wants to see their grass of their senior neighbor getting longer if they can send out Bob to knock out that. And indirectly, I mean, visitors to these homes and businesses, groups like HOAs are going to benefit. People get to come into these places, these of business, these homes, and see a beautiful exterior and interior because of this. HOAs get to send these robots into places to take care of the grass instead of having to manually hire a group to come take care of it. You don't have to hire landscapers. They can go, oh, your grass is a little long, send out Bob. Bob will take care of it. And these bots are going to create jobs. They're going to allow people to have more hands in creating something so marvelous. And also will lead to inspiration. People are going to see these bots. They're going to say, I can do that. But what if we did this? They're going to inspire the next wave of these robotic assistants for people. It's something where it can make a big impact for everyone.
Okay, our swarm design requirements are each robot must be weather resistant because we've got both indoor and outdoor robots. Total space occupied must be less than 24 inches squared. Our robots must be fully automated, and each swarm member must be able to communicate with the central hub. Our swarm bots and their human designers are Johnny 5, which is a vacuum bot, designed by myself, Nicholas Hawkins. Then we have Bob, the lawnmower bot, who's designed by Jose Hurtado. And then Dwight, which stands for Don't Worry, I Got This, is our surface polisher bot designed by Richard Wright. Okay, here we have Johnny 5, our indoor vacuum bot designed by myself, Nicholas Hawkins. There have been quite a few design changes from the original concept design. This is mainly due to the fact that some of the technologies needed for the concept aren't currently available. So several items were scaled down and simplified quite a bit, but I believe the final product here is better than the original concept and will also be cheaper to produce. Got several views here. This is the front of Johnny 5 here. Top view, this shows some of the internal components, which we'll go into more detail on the next slide. Bottom side view, back status lights, which we'll talk about in the next slide as well. And here you've got kind of a hood pop view with both the covers in place. Then for our internal components, we have a 9-volt power source here, the Arduino controller, 2 proximity sensors up front, 2 independent drive motors that drive these wheels here, and we've got a brush motor that's up, represented by this green right here, that drives this brush. This yellow part is our brush head. Purple cylinder here represents our vacuum motor. And this right here is the debris full sensor. Lets the bot know when the debris bin is getting full. And then showing here on the back of the robot, we've got our status light and also our on-off switch that can be controlled by the central hub. For our circuit design overview for Johnny 5, we didn't have a lot of changes from the original conceptual design. Biggest change was, instead of crab legs, we went with these drive motors that actually turn wheels. That was much more practical for what we were trying to do with this vacuum bot, and that was the justification for these changes. Here you've got your control board and the on-off switch here that central hub can communicate with, letting the robot know to start or to stop. Our brush motor, which is up here, and then our vacuum motor down here. We've got our 2 proximity sensors out in front. Here you kind of shows them detecting objects. And then our motor chip. This is what drives these 2 motors here. And then, of course, I already mentioned our 9-volt battery supply. And we have a status light, which is right here. It's actually a RGB LED. It can switch between red, green, and blue. Green being good, red being stop, and blue being that the debris bin is full. And that's what this sensor is right here. This is a flex sensor. It sits directly underneath the debris bin. As the bin fills up and that sensor flexes, it lets the bot know that the debris bin is full and that it needs to be emptied. Okay, I'm going to run us through some of the code here for our Johnny 5. We've got a nice flow chart here to kind of help us understand this code over here. Most of Johnny 5's code is split up into loops, and we'll just kind of use this flow chart here to help us understand how those loops work. We start off with a command from Central Hub to turn Johnny 5 on. This activates the brush and vacuum motors. Then we've got 2 main loops here, this one and then this one. These loops here control the motors and the proximity sensors, and these loops here control the status light. Just as a real quick example, if the brush and vacuum motors are on, it moves to this next step, and if the debris bin is empty, it activates the green LED. If it's not, it's going to activate the red LED if the motors aren't running. If the debris bin happens to be full and the motors are running, it'll activate the blue LED, letting the operator know and Central Hub know that the debris bin needs to be emptied. Over here we've got, after the brush and vacuum motors have been activated, the proximity sensors are going to check to see if they see anything. This action right here accounts for the condition of whether or not both proximity sensors are seeing an object. If they are, it's going to initiate a sequence where it'll kind of spin Johnny 5 in a circle until one of the proximity sensors is freed up or not detecting something. And this next one here does the same thing as well. This is for the left motor, and then this is for the right motor. And as it detects an object, it'll start or stop the left or the right motor to help Johnny turn left or turn right to avoid the obstacle. As soon as that object moves out of the way, it'll continue to move forward, which is this one here, forward right motor and forward left motor when there are no objects in the way. And that just keeps looping in a circle. until central command takes away the on command. Okay, here's a small demonstration of how Johnny 5 works and how the different sensors and actuators work together. I've got a small dip switch right here that represents the command from Central Hub for Johnny 5 to activate and vacuum an area. So we're going to go ahead and flip that on. You'll notice that the LED status light is red because Johnny 5 is off. Once he receives the command, after I click that switch here to represent that, we'll get a green status, meaning that Johnny 5 is good. This flex sensor right here lets us know when the debris or the dust bin is full. As it fills up, it flexes this sensor, and then it'll change the status of our LED to blue, meaning that the bin needs to be dumped. Once the bin is dumped and the flex sensor is reset, we'll go back to a green light status. The proximity sensors are working in conjunction with these two motors here. So as Johnny 5 sees an object on the right, the motor on the left will shut off, and the motor on the right will continue to turn, which will cause Johnny to turn left. And then as he gets further and further away from the object, both motors will resume turning, and same thing goes for the left. Once an object is detected, the right motor stops, left motor keeps turning, causing Johnny 5 to turn right. Again, once the object moves away, or once Johnny moves away from the object, both motors will resume spinning. And here we have our brush motor and vacuum motor that's triggered by that central command and on-off switch.
Hi, good morning. My name is Jose Upalo, and today we will be talking about my project robot, which is the lawnmower robot Bob. So this is essentially Bob's design, a very simplistic lawn mowing robot that'll help consumers cut the grass for them. And in doing so, prior to this, we can look at previous drawings in which showed the complexity of our robot. So then we had to, in a sense, simplify it in a greater scale because of the abilities of Tinkercad. So right here, this bottom corner was my robot, was the robot Bob. And then if we scroll down now, we will look at the updated version. So the updated version of this robot is now going to be just a simple robot. The components of this robot will have a housing, 9-volt battery, a height adjustment for the lawnmower blades. It'll have an Arduino Uno, proximity sensors, 2 wheels, 2 blade wheels, 2 independent motors, blade motors, and a trash can. So in running this circuit, this is how the setup will be. We'll have the Arduino, we'll have the 3 proximity sensors, 9-volt batteries, blade motors, 2 motors, and then we'll have a micro server, and it'll all be computed with the L29 3D H-bridge motor drive chip. This is the flowchart for the Arduino code. So it'll start off by getting the on command from the central hub, which will connect all three robots and tell them what to do and when to do them. So once this robot is activated, then it will turn on both the blade and the vacuum motor, as well as the wheel motors. So then as it begins to drive, it will ask the question of, are the sensors being disrupted? If the sensors are not being disrupted, then it'll continue to move forward until the sensor is disrupted. So then once the sensor is disrupted, it'll go through 3 steps into asking whether or not asking questions where it should go rather than just moving forward. So if it goes up and it says the center sensor is being disrupted. So if the center sensor is being disrupted, then both the motors will kick into reverse, reversing away from that disruption and then going back into the previous motion of asking whether or not the sensor is being disrupted and moving forward. So then if it goes down to it, then it'll go into the next one. If the left sensor is being disrupted, if yes, then the right motor will turn on to reverse and the left motor will turn forward in order to turn the robot to the right. And then once it's out of the disruption, it'll continue back on to moving forward until there's another disruption. So if it goes all the way down to it again, and then now that the right sensor is being disrupted, then the right motor will go into the right motor will go into forward, and the left motor will go into reverse, causing it to turn left. And then these are very simple aspects of the code because it is a simple robot that is just meant to be outside and just cut grass. So with that, it'll also have a parameter in which it will go and it'll just follow the outdoor line and cut grass. So this is the written code. This is the written code in order for the robot to essentially move, go, work. And so this is the written code for that. So now we go to our demonstration. So the demonstration aspect is we'll go to our Tinkercad and we'll start the simulation. So once we start the simulation, we'll see all three servos or all three proximity sensors working. And it is essentially going through the rundown of getting information from all three. But once we turn off the sensors and we go to the central one, we see now how both of these are turning right and left. So then we go to the point to which we are now driving. So now we are moving forward. We are moving forward. Both of them are at 231. And then if we would like, we just drop back down our objects and they come to a stop. So then now, once it's within the distance, it'll stop, it'll go through and see how now we have something on the left-hand side, it'll turn. We have our motors going at negative 138 on the left side and 184 on the right side, and then coming to a stop before reversing one more time and then proceeding forward. So the same aspect goes for the right-hand side. We go to the right-hand side and we now just await the point to which the sensor is being picked up and the distance. So now it's the same thing to where now, once it's within the distance, it is being reversed, and then the sides are, or the motors are being turned accordingly. So we have both our negatives, and then we go into the turn. So then once it turns and then it completes its stop, it'll hit 0. And then once it hits 0, it'll realize whether or not going through the code again, asking if there's anything in front of it. Once there's no object in front of it and it has adequate amount of distance, it will continue to go. And then once it completes its round, it'll complete its stop. And then once it goes to its stop, then now it moves forward. Uninterrupted, undisrupted, while we still have it continuously cutting grass, and the motors are turned on, and the wheels are moving forward. And this is the breakdown, all the components of the model, and that is the presentation for Bob. Bob, the lawn mowing robot.
As you guys can see here, the Delight Surface Polisher is a very simple beast, right? We've got various sensors on the top and bottom here, front and back, to demonstrate the pages. We have our display here showing the little polishing cloths, the wheels, of course, to get it moving around, and then an inside area here showing the various distance sensors that'll be on the front and back. There also will be two of these sensors located here in this top piece. as well as 2 batteries to run both Arduino boards that are needed required. And then we have 1 motor here that will, of course, run these polishing pads around the edge. So these 2 DC motors also will be responsible for running these wheels going back and forth, left and right, making sure that Dwight doesn't decide to take a quick tumble off an edge. So Dwight's circuitry is a little bit different than the other bots, as it requires multiple Arduino boards to compensate both for front and rear sensors, checking distance, as well as the motor it has to run to keep the polisher going. So below Dwight, you'll see there's 2 round brushes that continuously polish the surface it's on. So this is run by running 2 Arduino boards, which check the distance in front and behind it, as well as to each side of it, ensuring that Dwight has plenty of room to operate. If those sensors show that Dwight is within a range of falling or reaching a distance of an edge, Dwight will stop and it will reverse. Or if it's finished the end of its cycle, it can be turned off from the central hub as well. So as you can see from Dwight's flowchart, it's very straightforward. Consistently, it's polishing after it receives the on command from the central hub. It'll keep checking distance on all sides as it proceeds. As it successfully proceeds, it will either continue to turn left to right, depending on where it detects the edges, or it will continue to clean until it detects edges. Whether it's going forward, can't go forward, it's going to reverse, and it's going to restart the whole process, going to check distance each time. All right, as you guys can see from this demonstration here, see the distance here for this sensor. Left side is showing, oh, we're too close. Turn off the motor. Motor's not running on this side. Motor is still running on this side here on the bottom because the distance is over the amount required, over the 10 inches. This motor here is still running to keep the polisher pads going. Everything is acting as it should, making sure that Dwight can take care of it. He'll keep polishing your floors, your areas, all that you need. Showing this distance here being underneath that 8 inches. Will show it shuts off the motor so that way Dwight won't run off the edge for you.
For our collective behavior, we have a simple flowchart here to show how these 3 bots communicate with Central Hub and work together to complete various tasks around the house. There are 2 separate loops, one for the lawnmower bot and then one that combines the vacuum bot and the polisher bot. So the lawnmower bot runs based off of a timer. Once that timer hits 0, that's recorded in Central Hub will send a command to the lawnmower bot to begin, and it'll keep running this loop until that sequence is complete. Once it's complete, the lawnmower bot will get a command to return, and that mowing timer will be reset to 0. The vacuum bot is very similar. Only small change is there's a question here, is the vacuum bot debris bin full? If it is full, we're going to post the vacuum bot notification on the bot status light. That was the little blue light on the vacuum bot that lets the operator know that the debris bin needs to be emptied. And once the vacuum sequence is complete, we'll restart that timer and then activate the polisher bot. And then the polisher bot will run its sequence. And once that's complete, it'll go back to here and we'll start all over until the vacuum timer reaches 0.
Our entrepreneurial aspect. These robots are meant to be durable and long-lasting. The estimated value for these 3 robots will total $3,000. In relation to similar products on the market, the durability and the benefit of there being a central hub for all 3 robots to communicate, that adds value and technology. Considering a Shark and or Roomba for inside cleaning, these can cost up to $600 for the premium versions. As far as competitors for the outdoor robots, there are limited products, but these products alone range from $1,000 to $2,600. The lawnmower robots and the surface polisher are the new innovations into this market, and in doing so, that adds retail value to the bundle. Of course, each robot will be able to be purchased separately, but the idea is to sell them as a package in order to benefit the consumer most. This is looking at the commercialize. This is looking at to commercialize these products and have them in everyday households, veering away from the industrial market, providing a step into the future for the average Americans.
So as these presentations have shown, these little bots are going to make a major impact the amount of work that everyone has to perform inside and outside a household or a business. They're simple to run and use, and they're intuitive to handle problems that you'll run into in the household on their own. And the bots are going to revolutionize this cleaning industry. They're going to increase that quality of life for the customers that get to take advantage of them. In regards to the lessons learned from this project, I mean, we definitely dove in with both feet. We didn't worry about people not understanding what we were doing. And we really embraced the entrepreneurial mindset, building something fearlessly, creating a product that was going to make an impact on the customer in a positive way instead of just another dust collector to, you know, lessen the weight of their wallet. Our team did have a couple different issues throughout the time. We lost our team leader, minutes before one of the assignments was due. So that was definitely a struggle that we still were able to accomplish, great things. We still were able to reenact our design process, letting our communication be key throughout. And our team really did work hard to talk through asynchronous methods, primarily Discord and Google. There were setbacks, of course, like I said, losing team members hard. We had about a food poisoning that threw off one of our members, which was funny that it hit at that point too. Um, this project being as large as it was, if we had, to do it again, now knowing the full kind of scope, we definitely would have spent more time digging into everyone's strengths, opportunities, as well as, making sure communication was key in the case of losing a team member, making sure that people were communicating, hey, we're going to be out of this group, we're out of this team. Doing check-ins and progress updates definitely were essential to getting this project done on the same page. And this, of course, will allow us to pivot in the future as well, ensuring that any problems that arise, we can handle them